Our first experiment is the graphing with the tracker software. In this experiment, we are going to learn how to make a plot in our lab activities. For this purpose, you will need the tracker software. If you don't have, you can download it freely from its homepage using this link. Since the tracker requires Java, Java should be installed on your computer. You can download Java using this link and install Java before you install Tracker. Now, I want to show you how to use Tracker software to make a simple plot of your data tables on a video. If you need to watch the video again, you can use this link. On the screen that opens after running the tracker, a data tool analyze should be selected from the View tab. Then, a New tab should be selected from the File section. The opening page is the page that allows us to analyze the data. The data to be used in this experiment are on the Canvas system. You can reach them on the Physics 1 webpage from the Lab Report Submission section. The data tables include position data of a moving object at various times. For the first set, the object is at x1 equals 9.6 centimeters at t1 equals 1 seconds, is at x2 equals 20.4 centimeters at t2 equals 2 seconds, is at x3 30.4 centimeters at t3 equals t seconds, is at x4 equals 39.5 centimeters at t4 equals 4 seconds, and x5 equals 39.4 centimeters at t5 equals 5 seconds. For the graphical representation of this information, we go back to the tracker and define the axis on the software. For this, click New column, write column name as time seconds, and click New column again, and write column name as position centimeter. Now, the horizontal axis indicate the time and vertical axis indicate the position. After that, we can enter the data. After entering T1 and X1, to switch the next row, press Enter on the keyboard. After entering the data on each row, the position and time data are simultaneously recorded on the graph. To plot the graph, select Curve Fits from Analyze tab. If we examine the data, we see that the displacements in each second are almost the same, around 10 centimeters. This means that the position increases uniformly with time. This is consistent with the object moving with constant velocity. Since the graph of displacement versus time for an object moving with constant velocity consists of a straight line, we choose fit name as line. This line can be represented algebraically as x equals x0 plus v times t. Here, v is the constant velocity. It can be determined from slope of the best straight line fitted by the tracker, and it corresponds to the parameter A, which is equal to 9.870 times 10 to 0 centimeter to second, namely 9.870 centimeter to second. X0 is the position at time t equals 0 and it corresponds to the parameter b, which is equal to 2.500 times 10 to minus 1 centimeters. If we go back to the data, we see that there is uncertainty in position measurement, which is 0.5 centimeters. The position uncertainty calculated from the entered data is also here, which is equal to 4.057 times 10 to the minus 1 centimeters. Due to the uncertainty in the position, there will be uncertainty in speed calculation. This uncertainty can be observed by first selecting auto fit and then keeping mouse on the parameter A. It can also be calculated using this formula, where V slope is the slope of the best fit curve of your plot. It's the parameter A, which was found as 9.870 times 10 to 1 centimeter to seconds. The average is the sum of a collection of time measurements divided by the count of time measurements. Ti and Xi are ith, time and position measurements in the data table. Delta V can calculate explicitly putting all the values here. I want to touch an important point here. These calculations are for 5 position and time data. But you have 6 position and time data, so delta V value might be different in your work. To summarize, you're supposed to plot the position time graph, make table of the fitting parameters, and calculate slope uncertainties for each plot you have for each set of data. While preparing report, make sure that your report contains 3 plots with the corresponding tables. Each plot must contain fitting parameters and error analysis. You must calculate slope uncertainties clearly for each plot and report them with the corresponding slope values. When writing physical quantities, don't forget to write their units. You should compare all the uncertainty calculations and comment on the difference in the discussion part of your report.